Lesson 62 is about square roots and higher order roots, and then we'll also be discussing what the plus or minus sign means. First, let's talk about square roots. Now, when we square a number, we're talking about just multiplying that same number twice, like 3 times 3. We know we could write that 3 to the power of 2, or 3 squared, which is equal to 9. So when we square a number, we're multiplying it by itself once. Now when we take the square root of a number, like if we had the square root of 9, we're trying to think of the two factors multiplied together that would equal 9. And that would have to be a 3, because 3 times 3 equals 9. We've talked about that before a long time ago when we were first evaluating algebraic equations. We said that the answer to them could be considered the solution, or you could also call it a root, or you might say that that value satisfies the equation. So that's where that word root, we use that sometimes in algebra just to mean like an answer. So the square root, that's the value that if you squared it would get you back to the number underneath that radical sign. Sometimes you might just call that the square root symbol, but it has a name that's called the radical sign. So when you find the square root of a number, you're finding that root that if you squared that root, it would get you back to the number underneath the radical sign. So you could understand then, if you had the square root of a number like 9, and then you squared that value, that would just get you back to the number under the radical sign. It would just equal 9, right? Because the square root of 9 equals 3, and then 3 squared would equal 9. So that's basically the definition of a square root. And we can think of that just in terms of a variable. We could say the square root of x. If we squared that, that would equal x. Now, a lot of times in math, and in algebra in particular, we use different symbols to help us describe things. Like in Lesson 61, we were just using this symbol here to describe that something is a subset of a certain set. We use the symbol pi to represent the value 3.14. A radical sign, it actually represents a number. And in fact, if you just have a radical sign by itself, it represents the 1/2 power. So another way of writing that statement, square root of x squared equals x, we can write it like this: x to the 1/2 power squared equals x. In a similar way, other expressions like higher powers, if you had this right here, that means the cube root of x. When you have a little 3 inside that notch, you don't put a 2 like in the one above. You don't put a 2 inside that notch because it's understood if you just have a radical sign by itself, that means the square root. So if you have a cube root, you could cube that and get back to x. And so just like the square root of x, that square root symbol, that just means to the 1/2 power. Now this means to the 1/3 power. And so you cube that to get you back to x. And then let's do one more. Let's go to the 4th power. So the 4th root of x. You could raise that to the 4th power, and that equals x as well. And then you could rewrite it like this: x to the 1/4 power raised to the 4th power equals x. So that's what that radical sign means. It's like a power that's a fraction instead of a whole number. And remember our power rule for exponents: when we have an exponent on the outside of the parentheses, we just multiply it by the exponent on the inside. So like in x to the 1/2 squared, we just say 2 times 1/2, which would equal 1. And so that's how we get just an x, or x to the power of 1. Then 1/3 times 3 is 1, 1/4 times 4 is 1. Now the one that you use the most is the square root. And since you use it so much, it's a good idea to memorize the squares of a lot of different numbers. So right now, why don't we just go ahead and write down the squares from 1 to 15. So 1 squared, that would just be 1. 2 squared would be 4. 3 squared would be 9. 4 squared would be 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Those you're probably already pretty familiar with, but the rest of these 11 through 15 you may not be as familiar with those. But it will be a good idea to get familiar with them so you can recognize in some of the problems you'll be doing here in the next few lessons when you have a squared term. So 11 squared, that's 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. And so the square root of each of those numbers, that's the root that if you squared it, it would get you back to that original number. So if you had 225, the square root of that would be 15, because that's the root. If you multiplied it again by itself, 15 times 15, that would get you back to 225. So all of those numbers we have there, that would be a very good idea to memorize those and memorize what their squares are to get to those numbers, and then also what the square root of each of those is. Mainly because you'll be using those a lot in the next few lessons. Let's go ahead and do some practice problems. Practice problem A, I want you to evaluate the square root of 13 to 4 decimal places. And so what I want you to do is use your calculator to figure out the square root of 13. And if you have the squares of those numbers memorized, you should recognize right away that that does not have a whole number answer to it, because we just did the square root of 16, we know that's 4. The square root of 9, that's 3. That's the next number that has a whole number root to it. So get a calculator out and figure out what the square root of 13 is on your calculator. It depends on the type of calculator that you have. Sometimes you'll have to hit 13, type in 13, and then find your square root button. It'll be a little radical sign on it, and then you punch that button and it'll give you the square root of that number. Or you might just do the square root sign first, like most graphing calculators, that's how you do them. The square root sign first, then you type in the number, hit enter, and you get your answer. So the square root of 13 to 4 decimal places, that would equal 3.6056. Could round that last 5 up to a 6. 3.6056. Now just think about that. That is the root for, or the square root for this 13. That means if you multiplied that number by itself, you would get back to the number under the square root sign. So you might as well just go ahead and do that just to make sure you understand it. Do 3.6056 times 3.6056. And you should get right around 13. And actually, since you rounded up some, you'll get a number just a little bit greater than 13. Now, just for a little more practice, why don't you evaluate what the square root of 21 is on your calculator as well. So just figure out how to use your calculator to find the square root, and for this one, that should be about 4.5826. You can just round it to 4 decimal places like that. So most numbers, when you take the square root of them, you get an irrational number as a result, a number that cannot be expressed as a ratio of whole numbers. Or integers. I guess integers would be a better way to describe the irrational numbers. They cannot be expressed as a ratio of integers. So for example, like the square root of 25, you can just think, well, what times what equals 25? That would be a 5. So the square root of 25 is 5. You can do that really fast. But the square root of 21, I mean, that would take you forever to get that right if you were just trying to guess at what its value was. So you're supposed to use a calculator to figure out these square roots. It's just a whole lot more efficient method. Let's do another type of problem. In C it says, between what two integers does the square root of 31 lie? So what you have to do here is think of numbers that you know the square root of, one that's smaller, one that's higher than the square root of 31. And so just write down the square root of 31 and think of a number higher than the square root of 31 that you know what its square root is. It has a whole number, or it has an integer root. And so that would be 36, right? The square root of 36, that equals 6. Now a number lower than that would be the square root of 25. That equals 5. So it's between 5 and 6. The square root of 31, that root will be between 5 and 6. And you could check your work just to make sure. You could do that on your calculator and figure out what the square root of 31 is. And that's about 5 point, I'll just do it to 2 decimal places, 5.57. And so that is right. It is between 5 and 6. Let's try that on another problem. Figure out between what two integers the square root of 53 lies. Well, let's just think about a number higher and a number lower than the square root of 53 that we know the square root for and has an integer solution. Well, the square root of 64, that would be the next root higher than the square root of 53, and so that equals 8. And so then we need 7 as a root, so that would be the square root of 49. And so it lies between 7 and 8. And you could do that on your calculator to prove that. You could find out what the square root of 53 was, and you would see that it does lie between those two integers, 7 and 8. So the reason we're doing practice problems C and D is just to help you understand how square roots work. And this is also a good way to estimate the square root of a number. For example, if you didn't have a calculator, or if you just kind of wanted to see what an answer was, what the square root to a number was, without doing a lot of extra work, this is one way you can do it. You can figure out the square root of a whole number that's higher and lower than the square root of the number you're trying to figure out, and then you can figure out or estimate what its square root might be. Let's do another one. Let's evaluate E, and there we have the fourth root of 16. So what you would do there is just think what factors, 4 factors multiplied together would equal 16, and that would be 2, right? Because 2 times 2 times 2 times 2 equals 16. Now when they ask you to evaluate like a cube root or a fourth root, they're going to want you to get a whole number answer unless they tell you to use a calculator. But pretty much on all of the cube root and fourth root ones, you won't be using a calculator to evaluate them. You'll be getting a whole number answer, and you can just do those in your head. Look at practice problem F. I want you to just evaluate that. The square root of 25 minus the square root of 64. Now, a problem like that, you don't just subtract the numbers. You don't just say 25 minus 64. You have to take the square root of each of those terms first, then do your subtraction. So you would change this to 5 minus 8, because those are the square roots of those two numbers, and so you get a negative 3 for an answer. Now we talked about this way back at the beginning of the book. Every square root, there's a positive square root and a negative square root anytime you take the square root of a number. For example, negative 5 times negative 5 also equals positive 25. So when we're doing a problem like this, just understand that in our algebra book they're wanting you to figure out the positive result, and you use that in your evaluation. So we don't have to worry about negative 5 and positive 8 or anything like that. we wouldn't say that the answer to this is also a positive 3. Just be concerned with the positive square roots of these numbers. And likewise, like in practice problem E, negative 2 is also a root of that problem, but we're just going to be concerned with the positive roots for right now. Now, since we've kind of been talking about plus and minus, look at practice problem G. And this is about evaluating plus and minus signs. What if you had a problem like that, where it says 3 squared plus or minus the square root of 4? Well, what that means is that you're going to have 2 solutions to that when you evaluate it. So one of them will be 3 squared plus the square root of 4. The other will be 3 squared minus the square root of 4. So what you can do is simplify each individual term first, and so you would say 9 plus or minus 2. And so then you can just do 9 plus 2, which is equal to 11, and then 9 minus 2, which is equal to 7. And so I'll say 11 and 7 are the answers. Now I could have written this 11 comma 7, but I just don't want you to think that I'm writing an ordered pair, because that's how you write ordered pairs, is with a comma in between them. So I said 11 and 7. So that's all that plus or minus sign means. When you see that in a problem, that just means that you'll have 2 answers. Simplify your expressions first, and then have one where you do plus the next term, and then one where you do minus the next term. And you'll have 2 answers for that evaluation. So just remember, when they ask you to evaluate a problem with a root, they want you to find the positive root, especially if it's like a square root or a fourth root. Cube roots, those can have a negative root for an answer. For example, like this, if you had the cube root of negative 8, there's only one answer for that. That would be a negative 2. A positive 2 wouldn't work. Only a negative 2, because negative times negative gets you back to a negative 8. Square roots and fourth roots, though, you can have a positive or a negative root that will work, but just figure out the positive root on those. Okay, well that's all for lesson 62.